As we discussed in the last session, many companies were moving towards a blade architecture but weren't getting the benefits and the results that they expected to get out of the consolidation of their rack server architecture. So Cisco designed the Unified Computing System, which basically took a completely different spin on the Blade Center architecture, where we had a single, scalable, integrated system where we combined the network and compute and storage virtualization, and we had the ability to create what we call a stateless architecture that we can move resources around as we saw fit. And one of the main benefits is that we could actually cable it and manage it all as one system versus having to do that individually for every chassis that we connected to the network. So if we take a look at our traditional blade architecture, it required a lot of additional stuff. It actually required additional LAN and SAN connections for every chassis that you connected, and each chassis had to have their own LAN switches and SAN switches and their own management. And every time I added a chassis, I had to add more of those connections over and over and over again. So once again, I tried to get into blades to consolidate, but really I was just doing the same thing I'd always been doing in a much smaller footprint. So with Cisco UCS, we were able to actually embed the management into one system, no matter if I have one chassis of servers or 20 chassis of servers, 8 servers or 160 servers, I get to use the same management. I was able to remove unnecessary components like additional switching and additional adapters and additional management modules, because now I have basically 2 switches that do all of that for one chassis or 20 chassis or 8 servers or 160 servers. I was able to combine my storage and my data network into one cable over high-speed 10 gig connection. So I get all the bandwidth I could want to my servers. I get less cables because now I only need one cable for my traffic instead of 2, one for data and one for storage. And I get a much more efficiently cabled architecture that allows more air to pass through and actually saves me on cooling and power. We were able to reduce the power and cooling by as much as 1/3 because of the fact that we've reduced so much hardware from the design. We actually have a 63% more open design than what our competitors had in the past. And this system, while it can run bare metal workloads, was actually designed and optimized with virtualization in mind versus the other systems that were designed before or right when virtualization was coming out and maybe didn't take that into mind when they were designing their system. While we have a lot of technical advantages with UCS, in just hardware and technology alone, probably the single most important piece of UCS is our embedded management, or our GUI. With our single pane of glass, you can log in and you can manage all the network pieces, all the storage pieces, and all the server pieces for your entire system, which once again could equal up to 160 servers. And then if you actually move past 160 servers, you could add another pod of UCS, and then we have a free management tool for up to 5 pods that you can actually have a single pane of glass across more than one pod of UCS. The other piece about UCS is that we can actually extend that same management system to more than one type of server. So we can use the same management system for either blade mount servers, or if you're still using rack servers in your environment, you can actually bring your rack servers up underneath that management as well. So now you have one architecture to manage all of your server environments, not one for your blades and one for your rack mounts. The chassis itself is future-proof for today's technologies. So it's actually made to accommodate the new processors and support the amount of power that they need, whereas in legacy platforms, you may actually have to leave servers out of slots in order to have enough power to be able to power some server processors or some types of server architectures in other chassis. Our chassis is also zero touch, so as you add a chassis and as you add servers and cable those up to the fabric interconnects, they actually auto-discover. The chassis support as much bandwidth as you could possibly need, with 4 or 8 ports of 10 gig per side, and then there's 2 sides that are running in an active data configuration. So I could actually have 160 gig coming out of an individual chassis. And then with the new fabric interconnects and the new I/O modules that have recently come out, I can actually upgrade that 10 gig connectivity to 40 gig connectivity. The other part is that the cabling between the fabric interconnects and the I/O modules, which sit in the chassis, it can actually be what we call twin-ax cabling, and that can be very inexpensive to just add additional bandwidth. So I can cable for the amount of bandwidth I need. I could have 1 cable, 2 cables, 4 cables, or 8 cables in a chassis, and it's very easy to just add another twin-ax cable and provide more bandwidth to all the servers inside that chassis that need it. Please join me for the next lesson, 4.9 UCS Architecture and Components.